Need for shelter remains one of our greatest challenges. Building a traditional home is a slow, labor-intensive process, often taking many months. This timeline, combined with the high cost of materials, makes housing expensive for millions around the globe. This fragility in the construction timeline adds uncertainty and cost, pushing homeownership further out of reach. In an age of rapid technological advancement, construction remains a largely manual endeavor, creating a formidable bottleneck. As our global population grows, the pressure to find a faster, more efficient way to build has never been more urgent. On a clear, level piece of land, a new kind of builder arrives. Not a team of people, but a single, sophisticated machine. This is a fully autonomous construction robot designed to work with incredible precision. Its mission is to construct the essential structure of a house in a fraction of the usual time. It operates on digital design. Before it begins, a detailed 3D plan is loaded into its memory. This digital blueprint guides the robot with unwavering accuracy, translating information into a physical structure. It moves with quiet grace, a stark contrast to a traditional site. These machines can be massive gantry cranes or mobile tracked vehicles. Regardless of shape, the core function is the same. Execute a perfect build from a digital design with minimal human intervention. Autonomy, guided by sensors, lasers, and cameras, is its most revolutionary feature. These systems check dimensions and layer quality, comparing reality to the digital plan in real time. If it detects the slightest deviation, it makes instantaneous micro-corrections. This continuous feedback loop eliminates human error, guaranteeing a level of consistency beyond manual labor. The construction robot works on a grander scale, following the same principle. A nozzle on a robotic arm extrudes a continuous bead of material, following a pre-programmed path. The first layer sets, the nozzle rises, and a fresh layer is deposited directly on top. Each new layer fuses with the one below, and the walls begin to rise. The robot can create straight walls or elegant, sweeping curves. The digital plan guides every move, leaving precise openings for doors and windows. The layer-by-layer technique creates cavities for insulation, improving energy efficiency. This continuous process cuts build time, reduces material waste, and makes construction more sustainable and economical. This rapid construction requires specialized materials. Standard concrete is too runny and won't hold its shape. Instead, scientists developed advanced concrete mixes, a marvel of chemical engineering. They must be fluid enough to flow from the nozzle, yet thick enough to be self-supporting once extruded. These custom blends also cure in minutes, not days, using special additives like accelerators and strength-boosting polymers. The result is a wall built quickly that's incredibly strong and durable. 11 words. Beyond concrete, researchers are exploring materials like foam cement. 9 words. This lightweight option offers excellent thermal insulation. 7 words. Reducing heating and air conditioning needs and lowering energy bills for the homeowner. 13 words. Sustainable mixtures incorporate recycled materials like crushed plastic and glass, turning waste into a building resource while reducing costs and our environmental footprint. This technology isn't confined to labs. It's already at work in the real world. Companies can now 3D print a small house's basic structure in just 24 hours. These projects prove a bold idea has become a practical, life-changing reality. The process is standardized. A team prepares a concrete foundation, then the 3D printing robot is brought in. For 24 hours, the machine works methodically, printing walls layer by layer. By sunrise, solid walls stand ready. After the robot finishes, human crews return to complete the house. They add the roof, install doors and windows, and run utilities. This hybrid approach, combining robotic speed with human skill, accelerates construction from months to weeks or even days. From affordable housing models to rapid disaster recovery shelters, each printed house is a testament to innovation and a beacon of hope. The benefits of this revolutionary method are clear. By reducing labor, minimizing material waste, and shortening timelines, 3D printing makes homes significantly more affordable. This represents a potential democratization of housing, making a fundamental human right more attainable. Speed is another transformative advantage, particularly in times of crisis. After a disaster, a fleet of 3D printing robots can be deployed to construct permanent homes almost immediately, helping communities rebuild with unimaginable speed and dignity. It turns recovery from a matter of years into a matter of months. Beyond speed, this technology unleashes a new era of architectural freedom. Builders can design complex curves and organic shapes without significant cost, creating more beautiful, human-centric urban landscapes. Looking ahead, the next generation of construction robots will be even more capable. Future machines may use multiple arms to print with different materials simultaneously, or even install plumbing and wiring. We can also imagine teams of smaller coordinated robots working together to construct larger and more complex buildings. This new way of building offers a path toward more affordable homes and resilient communities. The image of a robot printing a home is a powerful symbol of a hopeful future, built with ingenuity, efficiency, and care. You're watching Invention Chronicles. Thank you for watching. Stay curious and subscribe to Invention Chronicles for more incredible discoveries that are shaping our future.